Okay, so problem 3 asks us to consider the following functions and determine which are inverses of each other. So, I guess an important thing to do here is to figure out what it is this question is asking us to do. So, our goal is to look for compositions that give us x. Okay, so where do we even start here? We can either pick a function, say like f of x or r of x, and compose them and simplify the composition and see if it gives us x. Or we can take f of x and try to solve to see what the inverse is. So maybe I'll try that first. And I'm only going to do one example of this. The solutions are posted on Blackboard, and I'd really, really like you to try these out on your own to make sure that you feel comfortable finding the inverses of a function algebraically and then checking your answer by composing them. So what is the inverse of f of x? I'm going to write this as y equals negative 6 plus 4x cubed. Right, that was our first step. Then we swap x and y and solve for y. So I get x equals negative 6 plus 4y cubed. Okay, so if I'm solving for y, the first thing I might want to do is add 6 to both sides. So I'll continue this up here. So I get x plus 6 equals 4y cubed. If I'm trying to solve for y, I can divide both sides by 4, which gives x plus 6 over 4 is equal to y cubed. And then I can take the cube root of both sides. So I get that the cube root of x plus 6 over 4 is equal to y, which is f inverse of x. And that's exactly what q of x is. So what I want to do now is I want to check to see if f of x and q of x are inverses. If they are, so I'm going to write if so, then we'll have that f of q of x is equal to q of f of x is equal to x. So this was in the first video of day 2 of section 4.6. So let's try that, see what happens. Oh boy, okay, so let's do q of f of x. So I'm going to plug in f of x everywhere I see an x in q of x. So I get the cube root of f of x plus 6 over 4. Which is -6 plus 4x cubed plus 6 all over 4. So I get the cube root of x cubed, which is just x. And you can check that f of q of x is also equal to x. I don't think that's really necessary for me to do here. But for example, on an exam, if I ask you to check whether two functions are inverses of each other, you do need to check that when I compose them in both orders that I get x. Which brings me to problem 4. So we're asked to show that log of x cubed and 10 to the x over 3 are inverses of each other. So I'm going to call f of x log of x cubed, and g of x 10 to the x over 3. Okay, so we're going to compose this in both directions and check that we get x. And if that does happen, then f and g are inverses of each other. So f of g of x is going to be log of g of x cubed, which is log of 10 to the x over 3 cubed. If I multiply those exponents, I get log of 10 to the x. And remember that if I don't have a base on the logarithm, that's assumed to be base 10. And I know that log of 10 to the x is x. So f of g of x works. Now we need to check the other direction. So g of f of x. So this is going to be 10 to the f of x over 3, which is 10 to the log of x cubed over 3. Okay, so I know that log of x cubed can be written as 3 times log of x. And then the 3's cancel out, so I get 10 to the log of x. And using our logarithm rules, and that log without a base is assumed to be base 10, I get x. So, conclusion. My conclusion is the following. So because we have that f of g of x is equal to g of f of x is equal to x, f of x and g of x are inverses. Which is exactly what we wanted to show.